Before I introduce the next speaker, who's also from Redis Labs, I wanted to make a little announcement. This day is about announcements, after all. So earlier today, we heard from Roy, who announced the GA of his Redis graph, but today we also released a new version for Redis PY, that's the Pythonic Redis client. The reason that's an announcement is because the client has been lying unmaintained for the last couple of years at least, but it took some effort from people in Redis Labs, including myself, but my peers, and we managed to start officially contributing to Redis PY as well as Jedis, a very popular Java client. And the announcement today is basically that Redis Labs is contributing to these clients and others down the road to make sure that you guys can still use Redis in the best way possible. But the next talk is from Redis Enterprise. I'd like to present Uri, who will talk to you about how we see orchestration, I think, in the enterprise. So please give Uri a warm welcome, and let's take it away.
Hi, everybody. I'm Uri. I manage the cluster group at Redis Labs. And today I'm going to talk a bit about Redis Enterprise and how we work in an orchestrated environment. So first, a brief intro into Redis Enterprise architecture and how we work in the containerized space in general. A Redis Enterprise cluster is a group of nodes with a shared nothing symmetrical architecture, where shared nothing means that the various Redis shards which run inside the nodes have no awareness of each other and are isolated to prevent them from affecting one another. And symmetrical, which means that the various nodes all know the same things and have all the required information to take over the various cluster roles. Each node is comprised of two layers. There's the control plane, which holds the various cluster management processes, zero latency proxy, and the web UI, CLI, and API frontends. And there's the data plane, which holds the various OSS-compatible Redis shards. Essentially, the Redis Enterprise cluster is a very fine-tuned and optimized orchestration framework dedicated to Redis. A bit about containers. Who here runs containerized workloads in production? Show of hands. That's actually a lot less than I expected. So containers are eating the world, right? They're easy to use, they're scalable, no more, it works on my machine, they're great. And when we containerized Redis Enterprise, we took the node in a container approach, which is far from the common best practice. And I'd like to dig in a bit into why we did things like that. All right. So what we have is a full node inside each and every container. And we did this in order to preserve a couple things. First of all, our ability to manage resources at a very, very fine-grained level. And second of all, to keep performance up. Now, for all Redis users, performance is king. And utilizing things like shared memory, Unix domain sockets, and various other things is very hard to do, if not impossible, across different containers. Okay? So we took the node in a container approach in order to still be able to do that. A bit about orchestrators. So with the current trends in microservices, orchestration is a must. It's not really a question. You need choreography. Your app has 20, 30 distinct containers running in it, and you need to be able to manage them together. And in order to do so, there's the various orchestrators out there. And I'm going to discuss briefly Pivotal Cloud Foundry and Kubernetes. So Pivotal Cloud Foundry, it's essentially an application paths. It manages storage, compute, and networking of containerized applications and VMs. You give it your code, and it will do everything else for you, from managing the VMs, managing networking, routing, cross-cloud compatibility, everything. And I know there's a session from Pivotal immediately after me, so you're going to get to hear a lot more about that. Kubernetes, the de facto standard for containerized orchestration, by far the most popular framework. And it acts as the back-end engine for other commercial offerings, such as Red Hat OpenShift and PKS, which is Pivotal Kubernetes Service. And it also manages the compute, networking, and storage for your containerized applications. And it provides for lifecycle management, and it works in a very declarative way. You declare what your configuration, what your desired state is, and it will do whatever it can do to get to that state. And now let's put them together. First, a bit about the challenges of having a stateful application in an orchestrated platform. And it's important to remember that up to about 2 years ago, state was a dirty, dirty word in the orchestrated environment, all right? You'd spin up your nice and shiny stateless application. It would be great. You could use all the nice little canary deployments, A/B testing, automatic scale up, scale down, everything. But your state would be in some bare metal or VM somewhere to the side, and nobody would talk about it. It was like the dirty secret of the family. And starting from about 2 years ago, people started saying, hey, we want to be able to run this stateful service inside our orchestration platform. We want to have the benefits of the orchestration platforms for it as well. And there's a lot of challenges involved with that. For starters, stateful services are by definition not cattle. They're pets. Now that's Kubernetes terminology, but essentially it means that each stateful service is unique. You can't just tear it down and bring a new one back up and expect things to work because you're going to lose your state. Okay? For us specifically, there's also the challenge of having to work across multiple orchestrators. So we want to be able to support Kubernetes vanilla. We want to be able to support PKS. We want to be able to support Red Hat OpenShift, Pivotal Cloud Foundry, and a couple of other orchestration platforms. And on all of these, there's slight differences. The ingress, how you handle traffic coming into your cluster, is different. How you package your deployment there is different. And also how you handle persistent storage. So in order to accomplish a good deployment across all of these services, we took a layered orchestration approach. And what does that mean? It means we utilize the external orchestrator, be it PCF, PKS, Kubernetes, and OpenShift again, to manage some of the functionality, while we use the internal Redis Enterprise orchestrator to handle the rest. And it's important to understand why we did things like that. External orchestrators are, by definition, they're generic. They're meant to handle a very wide array of various services. And while they do expose APIs and hook points, it's difficult, if not impossible, to migrate a very, very fine-grained level of control into them, especially when you consider that there's multiple orchestration platforms out there. Now, in addition, again, performance is king, so we have to have those fine tweaks. And we have to have a framework which allows us to maintain a common architecture across our various deployments. That framework has to allow us to have like under 10-second failover time and the ability to spin up dozens of shards or databases per second. When doing a layered or double orchestration, you have to be very careful with how you manage the boundaries
between the external and the internal orchestrator. Whatever you do not want one of them to pull one way and the other to pull the other. Trust me, it does not end up well. And specifically in Kubernetes, but this is pretty much the same for other orchestration platforms as well, we took the approach of having the Kubernetes orchestrator handling everything on the pod level, on the node level. So it handles scaling up the number of pods. It handles pod healing. It handles things like scaling them down. The Redis Enterprise orchestrator handles everything on the shard level. So it can handle scaling up and down databases. It handles database configuration, shard level failover. And together, they manage upgrades and service discovery. And a bit about how we did it in Kubernetes again, specifically. So we started out with static deployment files, YAMLs. This is how everybody starts up in Kubernetes. You have a whole bunch of YAMLs. It's fairly unmaintainable. It's hard to ship. It's hard to manage. And it's definitely hard to customize for specific customer environments. After that, we went for Helm. Helm is essentially a template/packaging mechanism for Kubernetes. And it allows much easier customization and shipping, but some platforms do not support it. And it still doesn't allow you to directly interfere or intervene in the way that the orchestration environment manages your stateful deployment. Finally, and this is what we have today, we have an operator-based approach. Operators are essentially the Kubernetes way of encapsulating all the operational knowledge required to run a stateful service or any kind of service inside of Kubernetes. So you can tell them specific behaviors on how you want your stateful application to behave. For example, I don't want to ever have an even number of nodes. And I don't want to allow the user to scale down the number of nodes if it means that the cluster will not have space for all the state. So I can encode all that knowledge inside of the operator. It will hook into the Kubernetes API on one hand and into the Redis Enterprise API on the other, and allow me to enforce these rules and maintain them in production. Finally, this is a bit about how our deployment looks. And so we have the operator. And as you can see, it manages quite a lot of things. It manages the Kubernetes stateful set, which is the standard way in Kubernetes to express stateful entities. It manages anti-affinity, pod disruption budget, secrets and configurations, which are all Kubernetes primitives. It also manages the services rigger, which is a component which polls the cluster and configures Kubernetes to expose services for each and every database. And it does all this programmatically, so there's no need for manual intervention. You have a custom resource definition on the Kubernetes level. It's exposed as if it's just a regular Kubernetes entity, and you can manipulate it as you wish via the standard Kubernetes tools. It's also very easy to take out for a spin. There's a detailed blog post in our website. Basically just a kubectl apply, and you're up and running. And you can do that on top of the various clouds on top of other platforms as well. And that's pretty much it. Questions? Anybody? Crickets. All right. Thank you. Oh, just a second. Here. Question there.
So if you have a deployment, so like if you have a deployment that sets it at like a base level, right?
Mm-hmm.
You want to do a deployment that kind of cascades a set of deployments. Would operators still be a good choice for that? And how would that work within, I guess, Redis and how is that like the combination?
So the question was, would operators be a good choice for a multi-deployment sort of situation, where you have a couple of deployments and they all need to be managed? If the operator, if the deployments have some sort of interdependency, then sure. I definitely see an operator managing all of them. If they're all completely independent of each other, then I'd go with a different operator per deployment approach. Any other questions? Thank you.